Hi, folks. I'm Anton here, co-founder of Chroma and Chroma's scientific advisor here with Kelly, our researcher in residence, to talk about our long context work. Kelly, why don't you give us an introduction? How long have you been at Chroma? What have you been up to?
Yeah, I joined Chroma in January, so it's been about like 6 to 7 months now. I did a project on generative benchmarking, and this was the second project that I did.
Yeah,
So it's been great so far. Learning
yeah.
a lot.
The generative benchmarking project was a real hit.
Yeah,
It was
yeah.
picked up in a lot of places, and it looks like our long context work is getting a lot of eyeballs too. So I figured this would be a great opportunity to talk about it a little bit more behind the scenes, go a bit beyond what's in the technical report.
Yeah.
Part of what makes science work is not just the final result where you're like, hey, look how smart I am. I got these great results. It's also talking about what didn't work or what we tried or the ideas, like how we came to the conclusions that we did.
Yes,
Just as
yes.
important. So why don't we start there? What was the motivation for the work?
Yeah, initially we were experimenting a bit with agent memory. So if an agent is able to like retrieve its like previous actions, like is it able to improve in like future unseen scenarios? And naturally, like experimenting with this, we're working with like agent benchmarks like SweBunch and WebShop. And although these are like very simple tasks, the models will like get confused. So I was like looking at the kind of like inputs that these models were working with. And a lot of them included a ton of like instructions, like tool descriptions, and like a very long chain of like previous like thoughts and actions. So it's very natural to think that these models will like get distracted and lead to like lower quality outputs.
That's right.
So I think that's kind of like what first led to us like starting to talk about this problem of context rot.
By the way, what is the lesson here? Look at your data.
Yes. First
Um,
lesson that Anton taught me.
yeah, I think that's right. Right, they generate these long reasoning chains, and
Yeah.
then one of the things that has always bugged me about the way that long context is presented in the literature or presented in various AI companies' marketing materials is this almost trivial benchmark of needle in a haystack.
Mhm.
Now, could you elaborate on what that is exactly?
Yeah, I mean, needle in a haystack is a very simple, like, retrieval task, essentially. You have a very long haystack, just like a long chunk of text, and you have a random fact placed somewhere within that haystack, and the model's job is just to, like, retrieve that one simple fact.
What are some examples of needles in
Yeah.
haystacks?
For example, you could have like a bunch of like program essays appended together, and then I think the first like original needle in a haystack test was it had a question that was like, "What is the best thing to do in San Francisco?" And the needle is just the best thing to do in San Francisco is to like go to Dolores Park and like do something, but it's oftentimes created with like lexical matches between the question and the needle. So the retrieval task is pretty easy. The haystack is like pretty unrelated to the needle and question as well. So it's a very simple task that doesn't really give you much insight into like how the model processes the rest of the input.
Yeah, it was a good first step at sort of validating, hey, can the model even find these tokens in its
Yeah.
input? But when we're talking about performing tasks, because that's what we want these models to do, right?
Right.
You want something that's more representative of what that's like, right?
Mhm.
And you'd like to understand like how those factors vary. And for me, this always sort of it was like a itchy part of my brain was like, in my experience, my practical experience of using the models,
Right.
I could see them even on remembering basic facts just kind of start to veer off as the context filled up, right?
Right.
Part of that, of course, is what they do behind the scenes, especially when you have like these long chats, like they do those compactions, right? And then they lose the facts as part of those compactions,
Yes.
which we didn't look into in this research, to be very clear, but I think it is important future work. But also, like, even in API calls where I should have had the context window, information that should have been present to the model, it wasn't found.
Yeah.
Right? And I thought, okay, well, intuitively, like, there's no real guarantees that they're processing this context evenly, right? Like, if you think about how they work, not necessarily.
Exactly.
So, what did we decide we needed to investigate?
Yeah, I think the first test that we did was like a very simple task, like text replication. And one test that I thought of was is a model, like we give a model like a series of repeated words, and it would have one like modified word in the middle. So for example, you can think of like the word like apple repeated 100 times, and then it has like the word apples, like plural, somewhere like randomly positioned like within that input. And the questions that we're asking here is like, is a model able to like count the number of like repeated words that appears? And is it able to like detect that subtle change within a series of repeated words? And I was testing this with like the latest models at the time. It was like GPT 4.1, and I think it was like Claude Sonnet like 3.7 at the time.
This was our original counting task, right?
Yeah, the original counting task. Yeah, so we're doing that, and like even just from like a few like thousand tokens, these models would already start to fail. It would just start generating up to like the max token limit. Sometimes it would just like refuse to generate,
Yes.
or we just get like random outputs,
Yeah.
which we thought was like pretty interesting because it kind of showed that even at at these like relatively like short inputs, like compared to like what models context window, these models still fail.
Yeah, on what is a really simple task,
Yeah,
right?
yeah.
Like you can write up a Python script and probably under 10 seconds. Like I wouldn't use that as a junior software engineer interview question.
Yeah,
But the model can't do it.
exactly.
In sort of in its head, right? Like you can imagine, even a grade school student could write out a word 100 times on the blackboard. So that was really interesting, and it sort of speaks to the fact that the models are autoregressive in nature, which is also important to remember. Output tokens can also be input tokens
Yes.
because the next predicted token is conditional on what's been decoded so far, right? And I think that when people think of context length, they're only ever thinking about the input.
Yeah.
So this like repeated word question was like our like think is like, how do these things actually relate? Fine. So we did the word counting task, right? Why didn't we pursue or publish that? It wasn't really in our technical report, right?
Yeah. We like expanded on like the repeated words task, and we did like multiple variations of it. But yeah, initially we didn't like include all of our insights from that because I think like we didn't really like vary like the position of like the modified word that much initially. I think I just like placed like the modified word like in the middle, but we wanted to experiment with like, okay, like how does like varying the position of this like affect the model's performance. So I think like based on like some of our findings from like that initial test, we kind of like expanded and then like look to like answering questions of like, oh, like does like the position of the modified word affect
Yes.
these models outputs, and like how does like varying like the input like also impact performance.
Yeah, it was also kind of difficult to control for the difficulty of the task versus the context
Yes.
length too, right?
Yeah.
Which is why we settled on our like current task, which is literally just replicate the input.
Yeah.
Right. Like even that simple task has a lot of variability, which we'll talk about in a minute. What did we land on then as our first like investigation of our context length specifically? Right. Is sort of our sort of extended needle in a haystack.
Yeah, yeah. So I think like needle in a haystack, like originally it's like a very simple task, and as you mentioned, it doesn't really test for like any like deeper processing from the model, but it's a very good task to build upon.
Right, because it has this lexical matching property, right?
Yes.
Which again, you can pretty much solve that with a regex.
Yeah.
So which is nice. It's like nice flat difficulty, but again, the thing that we want the models to do is semantic processing, right?
Exactly.
We don't want them to like match words. We want them to know, hey, like when I'm asking you for the profit and loss of companies in this industry, I don't need to tell you to use those exact words to find them in every report. You as the model should be able to observe
Exactly.
that, right?
And that's how people use these models in practice. You're not going to tell a model, okay, like look at these like specific lines of the report, look at these specific lines of code. You're just going to tell it a very ambiguous query.
Yes.
So that's something that we tested initially. Like a lot of these like common needle and haystack tests, they have like lexical matches between like needle and the question. But if we make it like slightly more ambiguous, but there is still like semantically similar, is a model able to identify that? And there have been some previous work done on this before called NoLima, like semantic matching, but this task often required the model to like have some external like roles knowledge as well.
Could you expand on that a little bit? What's an example of that?
Yeah, for example, like if I ask the model, oh, like where does Anton, like what city does Anton live in? And somewhere like in the haystack, it said like, oh, Anton lives next to Dolores Park. The model would have to know that Dolores Park is located in San Francisco.
Right.
This is kind of like knowledge that isn't like purely testing for semantic matching. It's also testing for like, oh, do you have this like external knowledge of this world and are able to like synthesize that together?
Right.
So we designed these needles in a way that it only tests for semantic matching.
Yes. In other words, only things that are present in the context.
Exactly.
Right.
Exactly.
Yeah. This is actually really important, and it puts our sort of test and benchmark in between these two, in between needle and haystack and NIM. What did we what are the different things we controlled for, and like how did we choose them?
Yeah, so we were controlling for like a variety of things. I think like one thing we wanted to ensure that like the task was like feasible for the models to do. So like even if like the questions were ambiguous, which we quantified by cosine similarity, can talk a bit more about that later. But we made sure that the models were able to like succeed at this task at short input lengths. And the only thing we would vary is like the length of the haystack. So we just like append more like polygram essays, maybe more like archive papers, things like that. We weren't adding any like additional distractors. And we also would like query the haystacks as well with the questions and make sure that there were no like conflicting, I guess, like facts that the model could like potentially like answer.
How do we figure that out? How do we figure out whether or not there were conflicting facts?
Yeah. So I basically like chunk the haystacks and then embed them and then put it into a vector database. I would query that vector database with the question and I would just manually inspect, I think like the top 10 or like 20 results that came up and make sure that they didn't conflict with like the content of the needle.
I think that's very reasonable. A lot of scientific work, again, look at your data. A lot of scientific work involves just really looking at what's falling out, and again, you are great for going through the slog of doing that. So we sort of ensured that one, only data available in the context, and then that the data actually was available in the context necessary to answer the question,
Exactly.
right? Okay.
Yes.
And then, so we made sure that it worked on short context lengths. So the thing that we're really trying to control for here is like task complexity.
Exactly.
Right? We're trying to make the task we're asking the model to perform to be even regardless of context length. And so context length is the only variable we're controlling for. It's a little ambiguous, right? Like, kind of intuitively, it feels like the task is more complex. But then when I fall back on how would I solve this with like with just programming, right? Like really the input length to a program doesn't make the program any more complex.
Right.
And that's how I was like trying to model this in my head, try to get intuition about it, right? So cool. We made sure the task works in the short context length. And then the first thing we wanted to vary is the context length.
Yes.
Right? So let's talk about that. What did we see?
Yeah, we did this in like two different ways. So one thing we experimented with was like how does like the haystack actually affect the needle. One thing we tested was like changing the content of the haystack, like with regards to the topic. So we're working with like two different topics, like polygram essays and archive papers. And we would like write questions that were like blended into like the polygram essay topic. So polygram often talked about like advice on writing. So we wrote like a question and a needle pair according to that. And then like archive papers tended to talk a lot about information retrieval, which was a coincidence.
The ones we had, yeah.
Yeah. So we would like write a question and like needle about that. So like the first thing we tested was like, oh, like that's the topic of like the question and needle pair and like how they relate to the haystack actually like affect model performance at all. And with that, we actually saw like some like non-uniform performance as well. Like I think on the or the archive essay, archive haystack, like there was like a pretty significant difference between like when we had like the polygram essay questions versus like archive needling questions.
Right.
So that's one test that we did. And another way in which we modified the haystack was like changing like the logical flow of the haystack itself. So typically in like the needle and the haystack test, they would just append like polygram essays like one after the other. So like within each essay, there's sort of like a like a logical like narrative flow. So if you just have like a random needle in the middle, that kind of like breaks like that logical coherence, right? So I thought that would kind of like, make the needle stand up more.
Yeah, I was surprised by this result too.
And like intuitively, like that makes more sense.
Yes.
Versus like if you just had like a very like random haystack, so you just have like random sentences and like none of that like makes any sense together. And if you just have like a needle within that kind of like blends in terms of like logical flow. So from that test, it was really interesting to see that like the needle that was placed in like the more like random haystack actually like made the models perform better.
Yeah, it's interesting, right? It's only a preliminary result because it was a relatively small scale experiment, but I think it's really worth investigating because we do present data to these models in a pretty linear way most of the time, or again, in sort of like a traditional RAG to the extent that RAG can be called traditional, having existed for 2.5 years. We present results in order of relevancy to the model, right?
Yes.
And it's kind of interesting because given chunking and given the way retrieval works, the model like does see those kind of results, right? Like the sort of like chunked up things where the sentences don't necessarily flow one after the other. And I wonder if that is accountable, like if part of RAG performance might be accounted for by the fact that like the information is like chunked up like that.
Oh.
It's
an interesting question.
I think it's worth digging further. I think this is like an easy project or experiment for somebody to run. So feel free audience to pick that one off the shelf and give it a go and see what happens. So, okay, we varied the haystack. We varied a bunch of stuff to do with the needle and question itself, right? By the way, I really hate how much we're mixing metaphors, but there's no escaping it, right? It's like we've got a needle and a haystack, great, same metaphor, but then there's a question, and it's like, no, everything's breaking down now. English language, can't live with it, can't live without it. What other things do we vary? For the needle, the haystack, the question.
Yeah. We would vary like the ambiguity of a needle in question, and we varied that by, we quantified that by cosine similarity. So essentially, we manually wrote like 8 different needles, and
Let's talk about that, actually. I'm really curious about that process. How did you manually write them? Like, what literally was the process of doing that?
Yeah.
What did you do?
Like initially, I wanted to write needles that were like topically relevant to the haystack, right? In order for us like to that test was like, oh, does like topic matter? So the first thing I did was I would like chunk the haystacks, and I would embed each of those chunks. I was just using text embedding 3 large, and then I use UMAP, HTTP scan, and that basically like creates clusters.
Okay.
So I kind of like sorted the clusters by size, like looked at the largest clusters. I picked out like the most like representative items from that cluster, and just like take a manual look at them. You can kind of get a sense of like, okay, like what kind of topics are like most prevalent. What is like the writing style of these haystacks? And from that, I was able to like derive that from the polygram essays. Like writing is a very common topic.
No, but I guess the question I'm really asking here is like, yes, we have this great process to like semantically distill the content of the haystack.
Yeah.
But you wrote these manually. Like, how did you come up with the thing to write? Like, how many did you have to try a bunch of stuff to get the similarities you wanted? How did you do it?
Yeah. I actually had to think about this like quite like strategically, because it can't be something that like it has to be like somewhat like opinionated. Like for example, like the question that I asked for the polygram essay with Haystack was like, what was the best running advice I got from my college classmate? That's sort of like a unique fact that the model can't just like, output like random tokens and like guess accurately. Like it has to be like very specific and like opinionated.
Yeah.
And for the archive like Haystack as well, like I asked a question about like, what is like the best re-ranker for like this specific use case. It has to be like highly specific, and like it has to be something that like the model can only succeed at by like looking at the haystack and like retrieving the correct needle.
Yeah.
So yeah, I kind of like had that in mind, and yeah, I think like you also have to write like 8 different variations of a needle too.
Which have a variation in similarity, right? Because you are in your head predicting the output of the embedding model at this point, which is not easy. Yeah.
And I had to like, I think I wrote out like maybe like 20 like different needles, and then I like ended up with 8. But yeah, it was just like a bunch of like trial and error.
Yeah, I wonder, this makes me think about generative benchmarking work, which was kind of similar, right? Like you have a bunch of chunk data, which is essentially our haystack, and then our generative benchmarking suite generates appropriate retrieval questions against it. Those are in a retrieval context. This is in our benchmarking context. I would love to see what it would like if we like slap these together and see if we can do it at scale by making Claude do it instead of Kelly. Okay, so we've got these. You've successfully written the like manual needles.
Yes.
So we're varying. So far we've like varied haystack structure.
Yes.
We've varied needle haystack similarity.
Yes.
And then we also vary needle question similarity, right? Mm-hmm. Yeah, let's talk about that a little bit, because like there's now this like matrix, needle haystack question similarity, right? There's like this 3 by 3, and we sort of like vary parts of all of that.
Yeah. So for needle question similarity, we wanted to like quantify similarity by cosine similarity, but we didn't want to be biased by like one embedding model. So I used 5 different embedding models. So I would basically like take each needle question pair, embed each of them, get the cosine similarity, and then average that out across 5 embedding models. Mm-hmm. And then from that, you kind of get like a ranking of like similarity. And we also got like a variation like less than like 0.1 as well. So that kind of like, gave us like a signal that like, okay, like this is like a pretty like consistent ranking of like similarity. And that kind of like gives us a confidence to say like, oh yeah, we like quantified ambiguity with cosine similarity.
Yeah. These are still, again, let's talk about results for a minute. These are relatively small scale tests.
Yes.
But they do, I think, point pretty significantly to the fact that context is not used evenly in all cases by the models, especially in more realistic settings. Because, for example, the logical flow thing is like pretty important, as we already talked about in a retrieval context. Yes. And then like, what was the impact of needle haystack similarity in particular?
Yeah, for needle haystack similarity, we we saw consistently that, having like a more similar like needle and like haystack pairing would make the task harder. So the models will like perform better, for example, if you had like a program essay haystack and like an archive related like needle in question.
Right. And which points to the fact that, for example, hey, like I, as the model, am reading like a bunch of financial reports and I want to extract the component from that financial report to perform my task. It's harder to find, right, than some needle that like stands out, lexically, for example, or semantically even. What about, and we've talked about the surprising results of like mashing up the haystack structure. What about the needle question pair similarity?
Yeah, needle question pair. We also saw that with I guess like lower needle question similarity, the models will perform worse. Like, I mean, these models like do like short like context lengths, but like as the input like got longer, like these models will start to like degrade a lot faster compared to if we had a high similarity needle question pair.
We saw something pretty interesting, right? I think at about, was it 10,000 tokens that we saw the inflection?
I think around like 10,000, 50,000, like somewhere around that range.
Somewhere there, and it's a pretty clear like step change in performance almost, which is really interesting. And I wonder if that isn't some sort of pre or post training artifact, right? Where maybe the conversations that the post training is being fed to the instruction following model are like 10,000 tokens long, and so they're like, I don't know what to do with the rest of this. I don't really care. Which, if you are training against the total distribution of conversations, maybe all the conversations are like biased down that end. We are now in the like raw speculation hour, right?
Yes.
The folks down the street here know a lot more than we do about this part. But I think there's interesting work to be done. What do you interpret the results to mean? Like, taking the results as they are, yes, the model doesn't performs ambiguity, like doesn't perform evenly. What do you think that means, like, based on your thinking about LLMs?
I mean, I think it has pretty implications for, like, how people use one context in practice, because I think, like, in all the scenarios that we tested, like, as the task got more, like, realistic, these models would perform worse. Like, as needle haystack similarity is, like, more similar, the needle question pairs are, like, more ambiguous. These models, I mean, are still dealing with, like, relatively simple tasks, but they perform worse. So that, kind of makes you think, like, okay.
Did we see that on reasoning models as well? Did we see that?
Yeah,
I think this is kind of important. Because we're asking the models to perform these autonomous tasks, and I really wonder how much of the performance impact is literally just due to the uneven use of context, not the task complexity, right? I wonder if we could control for this in other benchmarks, would we see like a performance jump if we just literally just controlled for length? I'm not sure.
Yeah.
It's, for me, and again, like wild speculation, and if somebody wants to work on this in the audience, I think it would also be a really good project. I think that there is probably some pre or post training bias that's causing this.
Yes.
And two, I think that regardless of what you're using as your like long context, you're using like rope or some other positional embedding, positional encoding, the attention heads that you have available, especially on the first pass over the context, have a finite representational capacity, and there's like a finite number of them. This is like raw speculation as well for me. Someone out there is probably thinking right now, Anton, you idiot, you don't know what you're talking about. But it's interesting to understand the biases that we're training into the attention heads relative to the position of things in the context and how they influence each other. And I think that this is work that could be done on an open source model like a Llama. You should be able to like see this impact in effect, especially if you have the compute resources to like train it in different ways and see what it'll do.
Yeah. I think this brought about a lot of like, I guess like interesting directions for like future research and like actually understanding, like how these models process input. And I think like just having like these long inputs, you're able to like reveal more like performance or I guess like specific like model behavior patterns that you're not really able to see with like short inputs typically.
Yeah,
so,
I think it is important. I do think. What do you think? Just like you mentioned, it has practical implications. What do you think people should do about this?
I think it points to the fact that obviously context engineering is very important. Like even if you give your models like all the relevant context, but you also give it some more like irrelevant context and maybe like distractors, your models are probably going to be less reliable.
Oh, we haven't talked about distractors yet.
Oh yeah.
We should talk about the distractors. Tell me about distractors. So what was the idea of like putting them in? What are they? How are they distinct from the haystack?
Yes. So I want to differentiate between like distractors and irrelevant content. So for example, if you're working with like the program essay example again, like the actual essays would be considered like irrelevant content because they're not really relevant to like answering the question.
Conditional on that similarity as well, right?
Yes.
Yeah.
And if you have, like a distractor, it would be something that's like maybe like the phrasing similar to the needle, or like maybe it's just like more like semantically similar compared to like the rest of the Haystack content. So for example, if you had a question like, what was the best running advice I got from a college classmate? The needle is, the best running advice I got was to like write every week. A distractor could be, the best running advice I got from like my college professor was to like write every day. So it's just like a slight like word change that the model might,
Yeah.
think is like more relevant, but it actually doesn't really answer the question.
Right. Yes.
So yeah, we wanted to test for that, like how.
So these are like adversarial elements
Yeah,
of the
yeah,
haystack, almost
exactly.
like deliberately similar, but not actually factually supporting. Yeah.
Yeah, yeah, and distractors are very common, I think, in like real scenarios as
I
well. Like
agree.
it likely to work with like, I don't know, if you have like a coding agent, maybe you have like very similar like, or like parts of like your code.
Function signatures. Or,
Yeah, they're very very similar. So I think like that's like one like motivation behind like testing the impact of distractors, because it's not likely that you're gonna have like a perfectly relevant like, I guess, like query and like relevant portion of the text and like everything else is irrelevant. You're gonna have some, like similar like relevant sections. So for distractors, we also like manually wrote like around 4 distractors as well. And for these, like we didn't like do like a robust test into like, okay, like distractor like needle or like distractor like
It
question
was
similar.
pretty binary, right? It was like,
Yeah.
does this impact conditional on context? Like, does it get worse with longer context, even though the number of distractors is the same?
Yes,
Right.
yes.
That was really interesting. I mean, we saw the same impact, right?
Yeah.
The longer things got, like the task isn't more complex. There's
Yeah.
the same number of distractors regardless of the context type, yet the performance falls off faster.
Exactly. That was really interesting to see. Like with like one distractor, like the models would like start to like degrade compared to like if you had no distractors, and then if you have 4, it was like even more severe.
Yeah.
But all the models were like, or yeah, most of the models were capable of like disambiguating like short input lengths. So I think like that's like the important distinction. Like the only thing we modified was like literally just input length. The task complexity was like pretty constant. So
Right.
yeah.
Okay. Time for wild speculation.
Speculation.
Is this a problem that's going to be solved at the model level, in your opinion? Like ever?
I don't know. I think I'm not gonna say it's like impossible. Like I think like our results are like just reflective of the current state of these models. I think, we're not necessarily saying that like, oh, it's like impossible for these models to ever handle long context.
Yeah.
Like I think like it needs some more like fundamental like architectural changes, which I think like maybe, we first need to like understand like how these like models are like behaving at like the internal like processing level of the model, and then maybe go about it that way. But I don't think it's like, I wouldn't want to say it's like impossible. Like I think there's some room for improvement.
I'm a little more bullish than you. I think that we can solve this in the current architecture.
Really?
And look, a lot of problems in LLMs can be solved by throwing more compute at it. Stargate has like 4.5 gigawatt more compute that they just got allocated, 4.5 gigawatt more electricity, which they can hopefully turn into compute. If the causes of these context biases are related to the statistics of the training runs, this can be mitigated, right?
Right.
And again, the thing that can help mitigate it is just like spending more compute to do it.
Yeah.
But you have to weigh that against, what do we really want these models to do? Like, what is the economic function of an LLM? I think, and this is sort of segue into our final sort of discussion here about our results. But their LLMs are this weird computing system, right? Like they can process semantic information, but we still want to treat them as deterministic in some way, because we want to know that they're going to be able to perform the task.
Yes.
Which is why this like inconsistent use of context and unpredictably inconsistent use of context is important. But if like doing business process automation is not the most economically valuable use of these models, then maybe this doesn't matter as much. Maybe it's not worth the cost, and we'll just keep making the models bigger until it doesn't matter. It's like, it's hard to predict, really. Let's talk about briefly about our last result before we open it up to the audience. So we started off with the repeated words idea just to see what would happen, and then that was like didn't really produce enough signal on its own. But we came up with a simplified version of that task, right?
Yeah. So for the repeated words task, I basically came up with like, I think around like 8 variations of like the common word and like the unique word that we placed. And so we basically like varied that between a bunch of like input links, and then we also varied that between like different like needle positions It's not needle positions, like the unique positions.
You can call it a needle. It's pretty much the same thing.
Yeah.
And,
So it's like,
and we had the model, like the task was literally just replicate the
yeah,
input.
just replicate this.
Yeah.
Yeah.
Literally just replicate the input. Again, like if it was a deterministic program, it would be trivial. By the way, when I say deterministic program, I think people get the wrong idea. I think people think that I mean the computation that the LLM runs is non-deterministic. And it can be if you like put the temperature up, but our temperature was 0, right?
Yes.
So what I mean by non-deterministic is you can't predict on any particular task how the model is going to perform before you actually run the task. And I think that like this is actually a big problem with economic adoption of LLMs. We want them to be deterministic. We want to be able to predict, hey, it's going to be able to do this task. I don't have uncertainty. I can like land that.
Right.
Anyway, so we had some really weird outputs and results for this task in particular, which I didn't expect. Like replicate your input should be trivial, right?
Yeah, yeah. So I saw some like specific like model behavior patterns, which I thought was interesting. I think like with Claude,
Now we get to do model psychology. It's great.
I think with like Claude Opus 4, I constantly thought it was like generating like copyrighted material. But
That's
it's just a
interesting,
series of
right?
repeated tasks. Yeah, yeah. Like I just told it.
Why that specific refusal, you know?
Yeah.
Yeah.
And sometimes it would say like, oh, I know this is like series of like repeated words and there's like one modified word. Because of this like inconsistency, I'm not able to like complete this task. And it just like straight up refuses.
Yeah, but you didn't tell it to like worry about that, right?
Yeah,
You
just
only said
replicate the
just
task.
replicate
Yeah, yeah.
the input.
Yeah.
Weird refusals, right?
Yeah, this is really weird. And then like GPT like 4.1 as well, it would just say, oh, I'm sorry, I can't complete this task. With like no reason, just like straight up refusal.
Did any of the models like write scripts instead?
Actually, no, there were
That's
no-
surprising too,
yeah,
right?
yeah.
Like you would think that your GPT would just write a little script and yeah, output this to its output. And it's like
Yeah.
that surprised me that none of them. I thought like at least at longer lengths they would figure out to write a Python script.
Yeah.
It's like it's a limitation on tool use on even the most basic tasks. Like this is almost the FizzBuzz. Like again, this is a task so trivial I would not give it to a junior software engineer.
Exactly. And then I think like with Gemini as well, I think was really interesting. Across like all their models, it was like 2.5 Pro, 2.5 like Flash, and then like 2 Flash as well. Like all of them start like generating like just completely random outputs. Like
That's interesting
Yeah,
too,
yeah.
right? Is it beyond some token length that they
no,
started doing
literally
that?
like from the beginning.
Wow.
Yeah, I
See,
think-
this is what I wanted to see. I wanted to see will it do that? Right from the beginning.
Yes.
What like random how? Was it just gibberish? Was it text?
Just like sometimes it'd be like kind of related to the word. So like one time I gave it like a series of like repeated like goldens. So it just said like golden, 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 like on. And then like it would just start talking about like the golden rule or like something like related to like golden and then
Yeah.
just like go off that.
It's
But then like
pushing it into that concept space,
yeah,
right?
but then like other times it would just like I don't even know what it outputted. Just outputted like a bunch of like dashes.
See, it's interesting,
It's
right?
really weird.
It's kind of like a new jailbreak, but only if you want the model to be insane,
Yeah.
right? Maybe the Borgs can get on that. We'll see. This like the results are really cool. From such a simple benchmark, we generated really interesting model behaviors.
Yeah.
Part of our research program at Chroma is to basically deliver results that you can use, right? So the application developer should know what to do with this
Yes.
now, right? With this work in particular, I think where we've arrived at as a starting point for a bunch of other directions, right? And I think that it actually is important to see how the models improve over time in relevant portions of them as a system, right? Like this, right? Like context engineering is the right word, and we need more information to like do effective context engineering. And so it's really great work. I think it's important. I hope the community picks it up. They already like kind of have, but we've learned a lot here. And now it's time to think about, well, how can Chroma the product, how can Chroma the company actually help our application developers to succeed here?
Yeah.
All right, shall we open it up to the audience? We are doing that now. All right, here we go. All right, I'm going to pull this over here, and I'm going to fire them at you. All right, Maxim asks, if I correctly understood the research, there was a lot of examples about finding needle in a haystack. This is very relatable for asking an agent something, but is context rot also relatable when an agent actually does something like writing code, editing files, meaning it produces code of lower quality when the context window is filled with, let's say, by 50, 60%? I would suggest that it does, right? I would suggest that our results strongly suggest that.
Yeah, yeah. Although like our tests weren't like directly testing for these like realistic use cases because it's like hard to design for like I don't know like a coding task that like keeps task complexity the same. I think like it does help.
Which is the important point here, right?
Yes.
It's very hard to keep a task like coding constant, but you could probably keep a coding benchmark constant and maybe populate the context window with like additional garbage to like fix the length and then see how it does.
Yeah,
That might be
maybe
possible.
That could be interesting to test out too.
Yeah.
But yeah, I guess like to answer the question, like I think like that is implied, like because these models like start to like degrade even on these like very simple tasks. If you have like an ambiguous retrieval task, like I'd expect like if you know give the model like a bunch of like code files, tell it to like do a task and like generate code. That's obviously like significantly more like complex and requires more processing.
See, this is where the replication result, like they literally replicate your output result, kind of gets me, right? Because a lot of rewriting code is literally just outputting the same thing that you just did with a minor modification.
Yes.
And again, this is an artifact of the way in which the model is order regressive. Like something there, something in the output attention is causing this to happen. And I wonder if like, again, this replication result where so much of code is like you're changing like one or two lines but outputting the rest as it was. Like I wonder how much of the performance degradation is again just from its inability to replicate its output.
Yeah.
Its input, I should say. So I guess the answer to Maxime is we think so. It's worth going into more depth on how much the context like changes this. It's kind of hard to disambiguate from the coding task itself, which is hard.
But I also would like to point out that like our just like based on our results, like the impact like probably isn't like directly proportional to like, you know, if you apply to like a coding task because like the model has probably seen like a bunch of like coding like scenarios before like during its training and it hasn't really seen like you know replicating like a series of repeated words. I think we chose like very specific like sometimes like synthetic like use cases, so you can't like say like oh because these words I mean these like models is so bad on like such a simple task it's gonna do like significantly worse on like you know like a coding task
because they're not really trained on this repeated words house, right? This is almost like AGI. It's not AGI complete, but it, like if it did perform well in this task I'd sort of be more bullish. So Philip Thomas is asking if he has a long context, should you put important information like the task at the beginning or end or both? What do you think our results suggest?
We had different results for this actually. Like for the repeated words experiment, we saw that if we place like the modified word at the beginning of the context, the model would be able to like identify it more. But for you know other tasks like needle and haystack, we also varied the needle position there as well. We placed it in like 11 different needle positions throughout the haystack, but that showed no like variation in performance.
Yeah,
like pretty consistent. So
only the length of the input really matters, right? Not so much the position within
the needle position. We saw no significant pattern from that, and we did this across like many different
input lengths and positions. We saw very little variability in the position, which kind of goes against at least Anthropic's suggestions for where to put important information in the prompt, right? Like for example, in their RAG prompting guide, they suggest to put retrieved results early, right? But we didn't see that variability. It would be interesting to compare notes with that team and see how they arrived at that conclusion, right? Lance asks, the recent Manus context engineering blog post, which I haven't read. Have you read this?
No.
Okay, I haven't read this. Talks about prompt caching as a nice way to manage cost and latency, but seems this does not get around any of the issues with respect to context rot if the cache is large. Did you do any testing with prompt caching in particular?
We did not.
We didn't do anything with prompt caching in particular. I don't imagine it would make a difference.
Yeah.
My understanding of how prompt caching works is basically you just fix the inputs for part of the context window and then you process the rest. And I think our results kind of like suggest that we did pretty much the same thing, right? We fixed and then added length and added length and added length. So it's like almost like prompt caching at various lengths, and we didn't really see too much variation there at all. I don't think it helps or hinders. Is my gut on this. I haven't read the post, but maybe we ought to and like give some feedback there, see what we see.
But I also wouldn't really expect much variation in results.
All right. The final question, the question everybody's been asking: are you an AI?
Oh my gosh, guys, I'm real.
I look. I promise that if and when Chroma develops an autonomous AI research agent, we will disclose it to the relevant parties. All right. Any other questions from the audience? All right. Looks like we're set. Well, thank you, Kelly. Great conversation. I hope that was enlightening. The thing I would like our audience to take away from this is there's a bunch of extra work here that that we would love to see people do. We're happy to collaborate on a bunch of this stuff. A lot of it is fairly lightweight. You can sort of pick it up and run with it and get an interesting or significant result like this one. So please do, tackle these things. Thanks for attending. Thanks again, Kelly.
Thank you so much, Anton.
Bye, folks.
Bye.